The next subject is of RD waveforms and loops. And tomorrow I asked you who is working. Tomorrow I asked you who is working with waveforms and loops, and about 5 people raised their hand. Yeah. What are the other people doing? You never look at waveforms and loops, because they are on your screen. Don't you know how to use them, or aren't they on your screen? That's possible. Watch. It's not so long ago, just a few years, we ventilated with this machine. It's a Servo 300, and there were no waveforms and loops. So it's possible that you use a machine that has no waveform and loops. Is someone using a machine without waveforms and loops? No loops, only waveforms. What machine do you use? Drager. Evita 4. Babylog. Okay. What machines do you use? I heard the Babylog. Avea.
And
Bird.
And we used to have also Sophie from Stephanie.
Okay, Stephanie. Okay. Ook, also. Fabian. Okay. What we are going to do in the next half hour, we must see, is that we are going to look at the importance of monitoring and interpreting the ventilator graphics. I want you to name the basic shape of that waveforms, and I want you to know how you can identify the different types of waveforms and loops. And as I told you, it was not so long ago that we used this one. But on this moment, on our neonatology department, we use the Leonie van Heine-Leuwenstein. And on our pediatric ward, we use 2 different machines. The Servo I from Maquette and the Engström Care Station from GE Healthcare. Do you know both the machines? They are not really NICU machines. Yeah. But it's still possible to close your eyes at this time for waveforms and loops. But most ventilators offer you the possibility to close your eyes, to make the waveform and loops invisible. Is anybody of you working with such a screen, with only numbers? Yes. Some people prefer a screen with one waveform. Yeah? It's sometimes possible to have 2 waveforms on your screen. This is nasal CPAP. And some machines offer you 3 waveforms. We prefer a combination of waveforms and loops on one screen. Like this. Yeah? 1 waveform or 2 waveforms and 1 or 2 loops. Who can tell me what the difference is between a waveform and a loop?
Waveform are more than 1 breath, and a loop is only 1 breath.
Okay, waveform is only 1 breath. Yeah? Loop is only 1 breath. And a waveform are 4 or 5 breaths. Yes, is that the only difference?
And the waveform are only 1 parameter, while loop are 2 parameters.
Yes, that's an important difference. Yeah. If you look at the waveforms plot pressure, volume, or flow against time. There's a time component in it. In a loop, there's no time component. Loops plot 2 parameters against each other. For example, flow and volume, or pressure and volume. Let's look at the 3 waveforms which are available on the most machines. We can see on the top a pressure waveform, in the middle the flow waveform, and below a volume waveform. Who isn't speaking Dutch can recognize what kind of ventilation this is. Think of the presentation from Daniel this morning. It's a pressure control mode. Why? It's correct.
Decreasing flow.
Yeah, what you see is that pressure is constant and flow is decelerating. Yeah? So it's a pressure control mode of ventilation. But this is quite different, a bit different. Anybody know this form of ventilation? If you're not working with maquette, you probably don't know the term. It stands for pressure regulated, volume controlled. You must think of it as a pressure controlled ventilation, but volume is targeted.
But how can you see on your screen that this is pressure controlled since your volume curve is also identical on every?
You can see it because of the pressure is constant and flow is decelerating. Daniela told this morning when you were using volume controlled ventilation, the flow is constant and the pressure is ramp. Pressure, flow and volume plotted against time. Yeah, you can see here on this X the time. The screen can also look like this. It looks a lot like the first one, only the colors are different. Volume control. Daniela spoke about volume control pressure, volume control ventilation this morning. He told you that pressure was a ramp, there was a peak pressure, a plateau pressure, and flow was constant. All remember? Yeah? What you can see here is that the patient is not triggering. How can you see that the patient is not triggering? Mostly you see the trigger here or here in a different color. Yeah? You can recognize 4 different phases in this. You can recognize the initial phase, where the patient can trigger. You can recognize the inspiratory phase, and you can recognize a plateau phase there and the expiratory phase. Notice this flow is returning here and here to 0. Is that always so? Is flow always returning to 0?
If the patient is obstructed, the flow...
If the patient is obstructed, the flow is not returning to 0. What will happen if, and I show you another picture from a pressure controlled mode, here. What will happen if there's a leakage? Will flow then return to 0? Or will there be flow and inspiratory? I think you're correct.
It's a positive. It's positive. When there is a leakage, for sure, on the volume side, the sign of the trace of the volume doesn't go back to 0.
That's correct.
It's a positive, always a positive, because the
Yeah.
leak is a positive flow.
But you can see that flow is interrupted here. Yeah? The people forgot to install in the new computer this one, so I can't use it. Hello? Hello? When we're looking at this waveform, what can we say? Is it pressure controlled, volume controlled? You must recognize this within 5 seconds. What you see is flow. And is the flow constant or is the flow decelerating? The flow is decelerating. In the middle you can see that flow is returning to zero. On the left, flow is really interrupted, and on the right, it's returning here to zero. Yeah? What can you tell about inspiratory time? In A, shorten.
C, longer.
Longer. In B, normal. Yeah? It's just so easy. Here you see inspiratory flows is returning to zero. Here you see expiratory flows returning to zero. Here also expiratory flows returning to zero. But what happened here? What you would expect is that flow was returning to there. Why is flow expiratory not returning to zero flow? I'm sorry? We're looking at the expiratory flow. Expiratory time is too short. Correct. Or how do you call it? Yeah, you can call it intrinsic peep. Auto peep. Yeah. What do you see here? Daniela spoke about inspiratory rise time. Is that correct? You can see here an inspiratory rise time that is quite long. Here can you see an inspiratory rise time that's quite fast. How do you make the choice to choose for a short or a longer inspiratory rise time? In what cases do you choose a fast inspiratory rise time?
It depends on several factors.
Tell me.
First is the builder rate.
The rate?
Which builder rate are you using?
Yes.
In this patient?
Correct. More factors?
Flow.
Who called flow? Flow, tell. What you see here is PEEP. Yeah? That's why the pressure curve is not returning to zero. It stays at 10 PEEP. Yeah? What are the reasons why we give PEEP? We give PEEP to prevent collapse of alveoli, and it's good for your oxygenation. Yeah? How do you recognize the trigger? There are two types of triggering. What you see on the left is the flow triggering, and what you see on the right is pressure triggering. I think all of you use flow triggering. Is that correct? No? Yes. In adults, sometimes they use pressure triggering. What's the difference between flow triggering and pressure triggering? In pressure triggering, you must trigger a negative pressure. You can see here, the patient triggers a negative flow of 2 centimeters of water. For children, infants and neonates it's much too difficult. Yeah, we always use flow triggering. What kind of ventilation do we see here? Which mode is this? You can't read it. Is it pressure controlled? Is it pressure or volume? Pressure. Yeah? Why?
Assist control. All
Pressure is constant and flow is decelerating. Is the patient triggering? Yes, the patient is triggering. Why? You see the purple part of the curve. Yeah? What's this? I heard somebody say leakage. I don't know who said leakage. Yeah, there could be some leakage.
leakage or something into trachea tube.
But why is it leakage? Leakage is for sure. Why?
Sure, because you see that the inspiratory volume and the expiratory is
Yeah. What we see here is indeed leakage. Yes?
But is it also
Yeah?
witnessed by the difference between the...
Yeah, you can see that there's leakage because there's 27 millimeters going in and 12 is coming out,
More than 50%.
more than 50%. What do you think? Does this patient have a cuffed tube? No, he didn't. No? This is a different one and a difficult one. When you're looking at controlled ventilation, volume control, pressure controlled, when does inspiration goes over in expiration? We saw that we targeted the pressure or we targeted the volume and we put a frequency on the ventilator. And we saw that the flow was mostly returning to zero. But in support modes, that's different. In support modes, you have to choose an end expiratory cycle or a cycle off time. A cycle off time is a percentage of the peak flow. So you can see that when you choose a cycle off time of 10%, that the patient has a longer inspiration time than when you choose a cycle off time, a cycle off of 40%. Inspiration is here shorter and here longer. Do you follow that?
It is too short. Can you close the aircraft, please?
Sorry?
It's too short.
If it's too short, you can choose up to, I think, 70 or 80. What will happen if you do that?
I was thinking that when you would close on aircraft, because,
Yeah. When you choose a cycle off of 70%, you've got a very short inspiration time.
Is that enough?
The patient will receive
Less
Volume.
Really less volume.
less volume because there's less inspiration time. So he will become very fast. Yeah. What cycle of time do we choose? I don't say it's always correct, choose with our neonates a cycle of time of 10%. Why?
In sick lungs.
Sorry?
For really sick lung.
Yes. But when we choose in normal neonates a cycle of time of 30-40%, what's standard on the most machines, we see all the neonates are going to hyperventilate in the machine. We'll give him a bit longer inspiration time. What are you doing? What kind of cycle of time do you use?
The lamp is releasing you it's
10.
10 to 15.
Yes. You must answer this question within 5 seconds. Are we looking at pressure or volume control? Is it control or is it support? Is there a fast or slow rush time? 1, 2. Pressure. Is it control or support? Control. Why? We don't see any triggering. Yes? What can you say about the rush time? Is it fast or slow? It's quite fast. I think it's quite slow. It's about, I think we put it on 10%. And normally you will see when you put it faster, it goes straight up. You give the right answers within 5 seconds. What happened here? What you see is that the pressure support mode is chosen. Why the flow is decelerating. And I can tell you that there is a short cycle of time and there is an enormous leakage. What will happen? Cycle of time. Who knows it? Who knows the answer?
Cycle of time is below the leakage.
Yes, cycle of time is below the leakage. So what will happen? There will be a very long inspiration. Can you explain it again? Can you tell again what you just told? Cycle of time?
I said that in B, the trigger threshold is below the leakage. So it means that the flow level will never reach that trigger level, and the inspiratory time will last for the inspiratory time set from
Do we see it often? We see it a lot.
It depends.
We see it a lot.
A lot.
But you see it, you only see it if you're looking at it. If you're not looking to your waveforms, you will never see it.
But in this case, there is a strange long inspiratory time
Yes.
to be a pressure support ventilation. So,
I will show you an example of a real infant in a few minutes. Yeah? Okay, for so far inspiration, what can you see on the expiration waveform? You can see this. What happened here? You see here a lower expiratory peak flow than here. And you can see here a long expiratory time and here a very short expiratory time. What happened here? Why? Peak flow longer and expiratory flow shorter. Something happened. Suctioning could be possible. Something else happened. Yeah. Patient received, I don't know, Ventolin or something else, but expiratory resistance was fewer here. When we're looking at flow waveform, you can immediately see that something's different here than here. What is different? This is the normal volume curve. Here you see an enormous leakage. Yeah? How do you see it? You can see it. Can you read what is standing here? It's a minute volume, 1.5 liters in and 0.1 liters out. It's enormous leakage. When we were looking at loops, then there are two loops. There's a pressure volume loop and a flow volume loop. Who's looking at these loops? One. Okay, we just saw that the difference between loops and waveforms is that there is no time component in loops. What you see is the volume plotted against the pressure. Yeah? How does the loop go? Let's hope the movie is working. What you see is inspiration, expiration. Inspiration, expiration. Inspiration, expiration. And that's what we saw. What is going on? Loop is starting here at no volume and no pressure. Alveoli are going to open. There's pressure. Pressure is necessary. Alveoli are open, and air is going into the lungs. Why is it strange that the loop starts here? Why is it strange that the loop starts here? Zero pressure. Yeah, there must be some pressure. There must be some beep. Yeah? Inspiration, expiration. What do you think will happen with this loop when compliance is changing? Right? Okay. She thinks the loop will go up when compliance is increasing, or going down when compliance is decreasing. Is she correct? You need a higher pressure. Yeah. This is what I told just, is the point where your alveoli are going to open. This is the point where pressure starts, more pressure, pressure. And here air is going into the alveoli. And here you can see the loop as we normally see it, with some peep. Yeah? Let's say this peep is 5 or 10, then your loop starts here. Pressure is going in, pressure is going in, air is going into the lungs. Yeah? This is what Maartje just told. You can see the loop changing when compliance is changing. What kind of ventilation is this? Pressure targeted, pressure controlled. Yeah? So pressure will be always the same. You can see that volume is changing when compliance is changing. Let's say green is the normal compliance, Red is the decreased compliance, and the yellow is an increasing compliance. You can see the loop getting higher when the compliance is increasing. It's the same, but now not pressure is targeted, but volume is targeted. You will see volume is always the same, but pressure is changing. Here the compliance is normal, here the compliance is increased, here it is decreased. What's this? It's overdistension. How do you recognize it? What's the difference between the loop here and the loop there? What you see here is volume going in, and suddenly the pressure is rising up, and not much more volume is going in. Penguin shape, they call it, I believe. Yeah, it's a penguin shape like loop. And that's the penguin. That's the other loop we look at. It's the flow volume loop. What can we see when we're looking at the flow volume loop? What we see above the X is inspiration, and below it's expiration. What is the most interesting part of this loop? Is it the inspiration or is it the expiration? I think the most interesting part of this loop is the expiration, and I'll show you why. What you normally see here is we start at zero flow and zero volume. Is it normal? Yes, that's normal. Because and expiration, there's no flow and no volume. Yeah? Above the X, it's inspiration, and below the X, it's expiration. And what you see is that expiration, in this case, is a complete straight line. This one is different. What you saw here was that expiration ends at zero flow and zero volume. Here you can see that it doesn't stop at zero flow. The answer is there. This could be air trapping or autopy. Did you ever see this in Charles at your unit? Yeah? What you see here is the different loop, the next one. You see expiration is not a straight line, but it's scooping. This could be a patient with airway obstruction. Yeah, what you see here. Peak flow is lower, expiratory peak flow, and you see some scooping in the loop. What you see here is that expiratory flow returns early to the baseline, early to the volume baseline. There could be some leakage. Why? Volume returns too early to the baseline. And then the one we see most often, I think, is the last one. It's this one. You were waiting for it. Yeah? Perhaps this patient needs suctioning. Yeah? Perhaps these are secretions. have some examples. I'm not going to tell you what it is, but I want you to tell me what it is. Yeah? They're quite easy, I think. I will start them again. What you see is that there's an enormous leakage. You're on a pressure support. And you see here an enormous long inspiration. It's the cycle off time. It's the cycle off. Yeah? Can you see this, or should we put the lights out? No? Sorry for my shaky hands. They are made with my mobile. So. What happened here? You see here a peak pressure. You see a peak pressure of 26 and a plateau pressure of 19. How do we get the plateau pressure? Because we are in pressure controlled ventilation. We made an inspiratory hold for about 5 seconds. What we see is peak pressure is 26 and plateau pressure is 19. What can we tell about it? No, I don't think there's any leakage. What is the pressure in the lungs of the patient? Is the peak pressure? Or the plateau pressure?
It means the resistive part of the curve.
Yes.
Maybe due to the smaller
Small tube or water in your system or anything else. But I think this is the more reliable pressure. How you get it? You get it only by choosing volume controlled ventilation, and you get plateau pressure, or by making inspiratory holding pressure controlled ventilation. Yeah? 5 seconds is enough. What's this? This is not a ventilator. This is a ventilator. You see peak pressure is 35. Enormous tidal volumes, don't look at them. It's a chart for 5, I think. Let's look in steps. Carbon dioxide, is it normal, low or high? 52. It's high. At what waveform? And yes, it's a carbon dioxide waveform and it looks obstructed. Yeah? This is an asthmatic patient. Yeah? Next step. What do you see here when you're looking at those loops? What can you tell me about compliance? What you see is a lot of pressure is needed before volume is going in. So the compliance must be decreased. What does the other loop tell you? Normally, expiration would go like this. Straight. And now it's scooping. Scooping was an obstruction. Yes? Next one. We're looking at the pressure volume loop. Yeah? Movie isn't completely sharp, but I hope you can see it. Think about a bird. The penguin. Do you see the penguin? Yeah? Still more pressure is needed and almost no volume is going in. Something wrong here or not? I will play it again. There's not much wrong. What I wanted to show you is that this loop is completely different than the loop I showed you earlier. The loop I showed you earlier went this way. By a different ventilator, the loop is going this way. Yeah? What do we see here? Try not to look as much to the volume curve, but look at the flow curve. What you expect in pressure-controlled ventilation is that the flow will return to zero. But this flow stops here. Why? Because of the enormous leakage. I think it is the last one, but I'm not completely sure. See, peak pressures high, and we made an expiratory hold. And an expiratory hold. But look at what happened when we did the expiratory hold. Look here. Did you see the number change? Is here some auto peak? Yeah, here's auto peak. And the most difficult one. I don't blame you if you don't know what it is. You can see it. Oh, he's sleeping. Will you dim the lights, please? better?
That's it.
What you see is enormous frequency. You trigger, 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 trigger. Could it be auto triggering? And you see what happened? The machine was auto-triggering. Not on a trigger from the patient, but on his heartbeat. Do you see auto-triggering a lot? Who does see auto-triggering?
Not this.
Not this, but the normal ones.
Quite a lot,
Yes.
unfortunately.
Last one. What do we see? Apnea, but not really. And no flow waveforms, and no volume waveforms. Any idea? Arterial dysfunction. Yeah? Everybody knows what it is? It's an expiratory flow sensor used on many machines, and it's completely full with pupil. Yeah? Then you can see all these kind of things. Was indeed the last picture from the loop.